Here's our review of quiz 4. In problem 1, in part A, you're asked to find the 5-number summary. Now, here's the 5-number summary. How did I get that? Well, what I did is I took those 24 numbers in the set of data and arranged them from smallest to largest. So you could easily see that the smallest one was 0 and the largest one was 8. The overall median, since we had 24 numbers, would have been the average of the two closest to the middle. That is the average of the 12th and the 13th on the list. They were both 3, so the overall median is 3. Q1 would have been the median of the lowest 12. So on the original list of numbers, ranged from smallest to largest, it would have been the average of the 6th and 7th on the list. And they were both 2, so Q1 is 2. Likewise for Q3, it was the median of the upper 12 numbers. So from the whole list of 24, it would be the average of the 18th and 19th. Now, the 18th was 3, the 19th was 4, so the average of that is 3.5. That's Q3. So in B, the range would be the difference between 8 and 0, the minimum, the maximum and the minimum. And the IQR would be 3.5 minus 2, which is 1.5. Now, in part C, we add one more, a new value that is 20. So that's easily the largest value. Now we have 25 numbers. The overall median will be the middle one, the 13th on that list, which is 3. The Q1 will still be the median of the lowest 12. That's still 2. But for Q3, the upper 12 are now such that the median would be the average of the 19th and 20th on that list of 25 numbers. So that's an average of 4 and 4.5, which is 4.25. So the new range is 20 minus 0, or 20. The new IQR is 4.25 minus 2, which is 2.25. Problem 2. In part A, it asks you to give an interval that contains 95% of the values. So you were given the mean was 18.6 and the standard deviation was 8. We are applying the 95% rule, which says that 95% of the values for a bell-shaped symmetric distribution lie within 2 standard deviations of the mean. So we take the mean and subtract 2 times 8 to get 2.6 for the low endpoint, and we take the mean, 18.6, and we add 2 times 8.0 to get 34.6. That would be the upper endpoint. So we would say that according to the 95% rule, roughly 95% of the data values fall between 2.6 and 34.6. Now in part B, one person in this study had a body fat percentage of 40.1. So for that person, we subtract the 18.6, the mean, and then divide that difference by the standard deviation, 8, to get the z-score, which is 2.7. Another person had a body fat percentage of only 3.7. So again, we take that number, subtract 18.6, divide the difference by 8.0, that comes out to negative 1.9. Even though it didn't ask for it, we could say that for that person with the 40.1% body fat, that person was 2.7 standard deviations above the mean. And likewise for the person with only 3.7% body fat, that person was 1.9 standard deviations below the mean. We were asked to tell which one is more extreme, and it would be the one with the largest absolute value for the z-score. So the person with 40.1% body fat would be more extreme. In problem 3, we're shown a histogram and we're asked first to estimate the mean. So you look to see what number looks to you like it's closest to the middle. I said roughly 69 inches, but we could differ because after all, you might say 70, another person might say 68. We're all in the same neighborhood. That's okay. Now, for part B, to estimate the standard deviation, we first note that roughly 95% of the area under the bars of the histogram lies between 62 and 76. We're going to use the 95% rule to estimate the standard deviation. So we first do that. Then, one way to approximate it would be to take the width of that interval and divide it by 4, and we'll get 3.5. Why does it work? Because that interval from 62 to 76 would be 4 standard deviations wide, because the 62 would be 2 standard deviations below the mean, and the 76 would be 2 standard deviations above. So the whole interval from 62 to 76 would be 4 standard deviations. So we take the width of that interval, divide it by 4 to get 3.5. Now, another way would be, since I've already identified the mean as being around 69, I could take the width of the interval from 69 to 76, and that would be 2 standard deviations. So I would divide that by 2 and again get 3.5. Now, again, we could differ slightly. To your eyes, it might look like the 95% of the area lies between, say, 63 and 75. That's okay. For this type of question where we're just eyeballing it, we could get slightly different results and we'd both be correct. So don't worry if you didn't get exactly 3.5. But you should be concerned if you got something like 15 or some ridiculous number like that. If you got something in the neighborhood of 3.5, then you're probably doing it right. Now, for the tallest person, you look at that bar on the extreme right. It's a short bar. We're not looking for the tallest bar. We're looking for the most extreme bar on the right. And I'm just estimating, because it doesn't have the number right below it, but I'm just estimating that that falls around 83 on the horizontal axis. So to compute the z-score, we take 83 and subtract 69 and divide by the standard deviation, 3.5, comes out to 4. Your z-score might differ if you had a different mean or a different standard deviation. That's okay. The point is just to be able to use the formula. And in part E, to interpret it, we would say that the tallest person is 4 standard deviations above the mean. I really prefer that you would say above rather than away from, because away from might mean above or below. So the more precise you are, the better the answer.